he'll say, I'll introduce you first.
Okay.
All right, everybody, welcome back to another OpenShift Commons briefing. We'll be live streaming on multiple channels on Twitch, Facebook, and YouTube, and questions from there. Today we have soon to be new, hopefully, Commons member, KPMG, joining us to give us a talk on their Ignite platform for, well, we'll find out what it's all for. It's machine learning, data science, all kinds of good stuff. But we have Kevin Martelli and Hongfei Cao, who I'll let introduce themselves in more depth and talk a little bit about the Ignite platform and how they're running it on OpenShift. And then we'll have a technical demo and live Q&A as always at the end of this. So please, Kevin and Hongfei, take it away.
Great. Thank you so much. And thanks to everyone for taking the time out to go through this presentation. Quickly, before we dive into the details, I want to quickly introduce myself. So my name is Kevin Martelli. I'm a principal software engineer at KPMG, overseeing our big data software engineering team. A lot of stuff related to cloud containerizations and end-to-end deployments with machine learning. With me, I also have a colleague, Hongfei Cao. Hongfei, maybe a quick introduction on yourself?
Yes. Hello, everyone. My name is Hongfei Cao. I'm a big data engineer director from Lighthouse KPMG. My specialty is on the big data analytics, distributed machine learning deployment, as well as cloud computing. Yeah.
Great. Thank you, Hongfei. So, as was mentioned, we're going to give you a little bit of a background around the motivation that we had on building what we call KPMG Ignite, which is our data science platform and ecosystem to bring use cases from POCs into production. We'll drill a little bit into what Ignite is, so the audience can get a feel for what we're doing with Ignite, how it works on top of OpenShift, and ultimately how it's used to produce business value. And then finally, we'll go into some architectural componentries of it. And then I think the last part here on number 4, which is the demonstration. And what we hope to do is through all the different parts that we'll take out, we'll walk through a very detailed technical demonstration. The demonstration will be representative of how the business can interact with it, how data scientists can interact with the platform, as well as how engineers can interact with the platform and how we can productionalize these pipelines on top of OpenShift within containers. So looking forward to this. And again, any questions, please feel free to type them in as we go. So the first question that many of you may ask is why did we decide to build and invest so heavily into this platform that we use for our internal data science as well as client initiatives? And probably like many of you could guess, one of the main drivers was just the explosion, if you will, of AI in the marketplace. Many clients, looking at it, to leveraging it, how can they use it? And we saw that there's a need there to kind of bring some of these technologies together, and not only from the standpoint of being able to, I would say, productionalize use cases. We do see a lot of people that are able to build cool POCs, but they're not always necessarily able to get them into a productionalized format. So one of the things within our Ignite platform is how can we come and bring these capabilities from both the POC to realize production. In addition, making sure we have those right hooks. So how does the business interact with the platform and our scientists and engineers? And again, we'll drill a little bit into that detail. But as we looked at that, there's really about 5 or so areas that we see that enterprises need to be aggressive in order to support AI and be able to bring AI more seamlessly into the organization. Some of these areas we do cover by Ignite, and then some of these areas have to be augmented with separate business processes. One of the important things here on number 1 is around data literacy and building out your data expertise. And we used to think about this more along the lines of something that an engineer, a scientist, a business analyst would do. But this is more holistically now across the organization. How do business folks understand their data? Can they get the right training data? Do they have access to the right data? Within Ignite, you'll learn we have different ways that this could be achieved. We have user interfaces. We have data sets from the technical side, which we'll talk through a little bit. The next is around technology. And I think we can all kind of agree that there's been a technology explosion in the space. Every day you wake up, there's new technologies available to produce similar types of outputs, and what technology should you use, what technology shouldn't you use, where do you want to do your R&D investing around. One of the things we took for Ignite is that we realized that this market was going to be expanding so quickly So we needed a very open ecosystem, microservices, containerization, easy to plug in and plug out as these new AI tools and capabilities came to the marketplace. And that's something that we'll show you too within this demonstration. Business processes. How do business processes now change? How are people relying on the data from data science? How are people embedding this into their day-to-day, work activities? How are the enterprises adopting this? And then the workforce. It's important that we enhance some of our legacy skill sets. We hire new folks, and how does our workforce support this? How do we move from sort of the legacy monolithic into these more agile, quick developing and productionalization of machine learning pipelines? And then the final part I'll just briefly touch on is around risk and reputation. I think we all know that there could be a lot of risk associated to some of this. The importance of understanding your model, understanding the details that are going into your model. How are you managing this? We see a lot of organizations, coming up with ways that they can have explainability and making sure that their models are fixed with bias, and how do you fix these things? So there's new risk and reputational risk that organizations are facing in this era. And again, these are some of the capabilities we hope that we can help support through the deployment of our KPMG Ignite platform. So with that, I'll jump down to, what is KPMG Ignite? And we touched a little bit on these topics earlier, but essentially we have the who, the what, and the why. From the who is this platform built for? Who were you having in mind that could use it? It was a platform predominantly built for our data science and data engineers, so they could build the pipelines. However, without having the business and the ability for others, analysts, et cetera, to be able to put input into the system, it just wasn't necessarily as I would say useful. So there's business hooks. So whether that comes from annotating and creating trading data, whether that comes from validating model results, there's different areas where the business and business analysts can come in to work within the platform. The what part. So what is it? And we talked a little bit before. This is a global AI platform. We have a very modular / microservice type of delivery. So each module, and we'll dive into that, could be an OCR job. A module can be a model. A module can be a data extraction. So we'll jump into some of these things, what these models are, but they're built in such a way that they're sort of interchangeable. So if there's a new capability in the marketplace that comes out and we want to take advantage of it, you can plug it into the platform seamlessly. And as capabilities deprecate, they can be removed from the platform. Then finally, the why. What we noticed is that, as we mentioned before, there was a high demand for these types of capabilities. But more importantly, as organizations sort of took their journey into the AI space and unstructured data and semi-structured, there was a lot of work around unstructured data sets. So loan documents or contract documents, PDF documents. How could organizations get the right information out of them, voice documents, et cetera, and make the correct business decisions? So this was really the why of this platform and why it was built sort of with an unstructured data set in mind. Again, going back to sort of the prior point, this was a platform that was built for data scientists as well as data engineers with those business hooks. And as we mentioned, it's very important that the business had a way to integrate into the platform to provide the right data sets, both from a training perspective as well as a data validation perspective, back into the process to making sure that we were building the right models, deploying the right models, and kind of meeting the business requirements and expectations. And then the modular component architecture. This is, I would say, the crux of what we built our platform on. We're really building it on the foundation of very small capabilities and services that could be interchanged with other services, so you can string together a pipeline to produce some type of output. For example, maybe a pipeline is you need to OCR a PDF document. You then need to break down that PDF document so you can start making business decisions. So maybe you add some spacing into it to enhance it, or you might do some sectioning of the document, and then ultimately you might make some type of business decision on it. All these different components are modular and kind of executable by themselves, or you can call different components that may reside in different cloud providers, whether that's GCP, AWS, or Azure. Another area was that it was you could be deployed via containers, or it supports RESTful services into the platform based on the demand that you need to push through. And then finally, it's around reusability. So all these components, are reusable. So if one person creates a component in the community, and that component has the capability of doing something, that component gets checked in, can be re-leveraged, and then rebuilt into an image and ultimately brought back into the platform. And again, some of this might be a little confusion through the talk, but once we drill into the demonstration, I think it will become a little bit more real. And then finally, it unlocks the value of unstructured data with surgical precision. So one of the things that we really want to do is be able to get out that content in documents that are able to help the business make decisions. And many times you'll have hundreds of pages of documents, but there's only certain sections or clauses or dates or information that the business needs to be able to make that business decision. And how do you get that information out? And that's all part about this pipelines that can be built on top of the platform, about how this, I call it, the documents become mature and more enriched, so you can start extrapolating out the right information to then be able to make the right business decisions.
Looks like we might have just lost Kevin for a second here. Hong Fei, are you still with us?
Yes, can you hear me?
Okay, there we go.
There we go. And is Kevin coming back?
That was definitely a hard cut. So that was like power or internet outage.
Yeah.
That was not a soft one.
Yeah, no, we'll give him a second and see if he comes back. Not. Kevin looks like he's logging back in. That's what I can tell. So we may have a reset on this slide. And for those of you who are watching, thank you for your patience. And for those of you who are thinking about the video that's going to be produced from this, not to worry, I will cut out the silent part for future use. See if we can get Kevin to reboot. Someone has Kevin in a back channel at KPMG, and just let him know that he's no longer talking out loud. He may not know.
Yes.
Yes.
Okay, we just lost.
Yep, we lost him completely there.
Okay.
So Hong Fei, if you want to put up the slide deck and put it back to that spot, I know you have a copy of it, so.
Sure. Let me share my screen.
All right, thank you. And we haven't had this happen in a while, so thank you all for bearing with us. And we'll see if we can have him dial back in. I'm sure he knows now that he's not online. Give him a minute. And if not, Hong Fei, can you speak to these slides, or should we pause and maybe? Oh, here he comes back again. I can see him popping in and out. So
He said he's joining back. Yeah.
He's coming back slowly.
Ah, the joys of working in the times of COVID.
Yes. Good. All good. We'll get there. But we're really excited to see OpenShift as part of this solution. And so the longer we stay on this slide with the OpenShift container orchestration bits in there, that's not a bad thing.
Can you guys hear me? I'm sorry, I'm back on.
Yes,
yeah,
we can.
We just don't have your video.
Hey, sorry about that. We have a.
Oh, it's dark there.
Yeah, we have a pretty.
Dark.
We have a pretty bad storm coming through, and we lost power. But I think I'm still on.
Yeah, so just reset and start talking as if you were at the beginning of this slide, and we'll motor on.
Sure. Yeah, and then we'll get through the demonstration. So sorry about that. So as was mentioning, Ignite is our data science platform, and what we're showing here is the I apologize again. My computer restarted. My email went on.
Everything's probably restarting right now. So and we can see it's pitch black behind you. So if we lose you, what we'll just do, we'll motor to Hong Fei's demo part and come back to this. So
that's fine. That's fine. Let's just see where we get through. So anyway, so as I was mentioning, Ignite is really, made up of many different layers, as you see here. And what I guess I want to talk about is what I call sort of the foundational pieces that make Ignite. And we really break it down into these 5 buckets. So a loom is really the main mechanism of how Ignite communicates from one component to another. And it's a proprietary data type or data element that we use here. But what it does is it allows for one component to receive data in and push data out in a consistent way. And a loom is really nothing more than an enhanced JSON. The next is we have our data science notebooks, which many of you are probably familiar with. Within the data science notebooks, you have the ability to create and your own pipelines and workflows to test them, to build them, and then to deploy them. The data science notebook themselves, it's done through Jupyter Hub, and then each user will get sort of their individual notebook. And then we talked about a little bit around how the business and users can get in there. And we have 2 main mechanisms. We have the annotation UI, which Hongfei is going to be able to go through in our demonstration, which I think is pretty powerful. How business users can then annotate documents, and those annotations are ultimately fed in to feed the models. And then there's some management UIs as well. And these are areas where you can build workflows and string things together in a more user-friendly way versus building it out through different code bases. And then finally, one of the things I think with a gap in some of the other areas that we deal with is around model management and the ability to manage your model, understanding the statistics associated to your model, many times feeding into your model governance process, as well as serving up models. And I guess one last thing I want to show on this slide is if we sort of understand the platform, I want to walk through from the bottom, from the pools of persistent volumes, up through kind of the application layer, just to give you a feel for how the platform itself works. So at the bottom, we have persistent volumes for our OpenShift cluster that are attached into the cluster. And if you move one layer up, we have our core infrastructure. So what we use is we use distributed min.io to facilitate object storage, which gives us better latency, faster read and write times. We also have a Postgres database that stores a lot of the metadata associated to the processing and the workflows. We have our logging and reporting within Kibana and Elasticsearch. We use Kafka as our message broker. So Kafka is really set up in a way that allows you to, as you execute one component to the next component, Kafka is a way that keeps the queue for the next component to pick up. And then finally, everything's executed across the containerization platform and orchestration through OpenShift. We move up one more layer. You'll look here, you'll see a lot of the components that we talked about before. So we'll have a component that just does OCRing and test for error.
Okay. Your sound quality is breaking up a little bit.
And you can scale that up and scale that down as much as you want. So we have some clients that may be running millions and millions of documents, and they may, is it in and out?
Yeah. So it's going in
maybe
and out.
I'll have Hongfei.
Yeah. So what I would say is turn off your video. Yeah, you've done that, and on your machine as well, and I've turned it off here. And I'm expecting that you're probably using your cell phone. Yeah, you're really breaking up, Kevin. Apologies for this. So Hongfei, if you can take over describing this this chart, and we will endeavor to edit this into something.
Sure. Can you hear me okay?
Yep, perfectly.
Awesome, great. All right, I will take from there. As Kevin mentioned, the whole Ignite platform is designed for data science and data scientist and the data engineer, right? For so to build arbitrary machine learning pipeline, and also easily collaborate for different business use cases. So in this architecture, I think Kevin covers persistent volume core infrastructure. On top of the core infrastructure, we have our the microservices, right? For each infrastructure component, we deployed in a secure OpenShift environment, and exposed as the API, right, for end user to access. And on top of the infrastructure, we have our machine learning pipeline component. You can see we have some pre-built, the model, like the Ignite OCR test run model, NLP Spacey, machine learning model manager, model deployer, and intelligent domain engine. So those will be its own microservices, has its own Docker image, and it will deploy at its own part. Later in the one of the demo I'm going to show you later, you can see how we create and customize each machine learning component and execute it using NAPLAN platform on OpenShift. Okay. So moving on to next page. So here is another view, like to show you the high-level architecture about the Ignite platform and how we deployed on OpenShift. After that, I will show you the actual deployment using our secured OpenShift. Right. So as we mentioned, so the whole deployment is the container-based, and it can plug in, right, different shift, right, to on cloud infrastructure, OpenShift, or on-prem VM, or the on-prem, like the private cloud. We deployed the whole platform using the CI/CD pipeline. So the CI/CD pipeline can help us set up the secret config map and all the the infrastructure component deployment, including the Kafka, Ignite API, the Elasticsearch, EFK, etc. And once we have the infrastructure component deployed there, we can then use the Jupyter Notebook as our data science platform to customize and build any arbitrary machine learning pipeline or workflow using the predefined component or Docker image. Here we show one of the workflow we built using this Ignite platform. It starts from the raw PDF scan PDF, and we can run the test writes, generate the OCR raw text data, and we can do some sectioning, right, to segregate different text right into each section, and run some NLP processing through the Python Spacey library. And we have our Ignite customized component called the intelligent domain engine to extract certain interest field, right, such as contract number, contract borrower name, etc. At the end, we have a handwritten detection component. The whole model is also, the machine learning model is also deployed and version controlled using MLflow. For those if you're not familiar with MLflow, it is an open source Apache project which offers version control and centralized storage for any machine learning model, and support Python scikit-learn model, as well as other Spark ML model in Parquet format, the TensorFlow, right, PyTorch model, etc. So we're leveraging the MLflow as our model storage, and we have our building component called the model deployer for the deployment. Okay. So without any questions so far? Okay. All right. I think we can move on to the demo. So for the rest of time, I have 3 demos for you. The first one is I'm going to show you how we deploy the Ignite platform to a secured OpenShift platform. And then followed on that, I will show you how to leverage the Ignite platform on OpenShift to do the annotation and using the MLflow to manage the complete lifecycle of machine learning model. Start from the data preparation, how we can use our annotation UI to prepare the training data, testing data, to generate the label for our supervised learning model, and all the way to the model prediction, classification, and we have interface application tools for you for end user to correct the model output. And the last demo, I will show you how to use a Jupyter Notebook to customize and create an arbitrary machine learning workflow pipeline using the predefined Ignite component. For example, the Spacey, in the Tesseract, OCR, and IDE. Okay. Without further ado, let me jump to the first demo. As you can see, we are deploying the whole Ignite platform into this secured OpenShift platform. And let me quickly jump to the components we deployed. As I mentioned earlier, we are using the CI/CD pipeline to help us deploy all the infrastructure component for Ignite platform. And also set up the services routes, right, for any API or web application we expose to the end user. Also, the CI/CD pipeline will help us, customize and configure the service account, right, configure the map, and make sure the security is placed properly. As you can see, we have several pods, the whole Ignite platform deployed there. So you see multiple pods running at this point. And for the data scientist or data engineer, we have the Jupyter notebook for them, right, to the test or develop, right, a new machine learning pipeline. You can see each data scientist or engineer and user, when they log into our Jupyter Hub notebook, they will create their own pod. So they have a segregated environment for them, right, to test and develop. So they don't need to worry about access control or other users, right, accidentally change or remove their code. Okay. The whole Ignite platform.
Hey, Hanfei, can you go into IQ first?
Sure. So it's IQ, yes. Right. So let's quickly jump to the Ignite IQ demo, and then we can come back to the detailed Ignite platform deployment on OpenShift. So here is the tools for data scientists and the data engineer manage the machine learning model. The backend is we are using the MLflow to store and version control the pre-training model. It actually includes the whole serialized binary of your model. So these tools basically help you. It's like the model store. So you can use these tools, right, to check and review all the existing model from in MLflow, and also you can manage and create a new model through this web application. Here, I'm going to show you. I already logged in as an admin, so I can look at in this Ignite model workspace. We already have 3 models created, and also let me jump in one model here. So this model is called start date. So what happened is we were processing a bunch of financial services contract documents, and the model will automatically extract the content from the raw PDF to get the start date, right, for this contract. And we don't rely on any predefined template. This is a purely NLP and machine learning model. Okay, so the first thing you want to do is you want to create the model using this Ignite IQ admin tool by giving the model name. What's the status of this model? The first status is always a setup, meaning you give the model name, you set up the target accuracy you want to reach for the model, and you start prepare the training and the testing data set. So at that point, we are moving to the annotation stage. Once the training data testing data set is ready, we'll move on to the modeling stage, which we'll train the model and validate the model using the testing data set. At the end, we have a holdout data set for you to really validate and test your model without actual true ground truth label. And at this stage, we have the user interface for the end user. They can go to the model result and manually correct or accept the model result. As the last stage is complete. Okay. So when we save the model using these admin tools, what happened is in the backend, the MLflow it will create an entering project in the ML flow for this model. Let me quickly show you here. This is the backend ML flow engine. As I mentioned earlier, this is used as our centralized model storage and model database. It provides a version control and also some type of model serving. But for the actual Ignite workflow, we have our own model serving component called model deployer.
And Hanfei, maybe one thing here is I think a lot of the data sets that are being part of this ML flow are ultimately feeding back into the governance processes that organizations may have. So a lot of these statistics and data sets that are coming out, your confusion matrix, et cetera, can then feed back into the overall governance process of your model management.
Yep, absolutely, Kevin. So as you can see, we have several runs already for the same start date model. This is the training set model. You can see what's the accuracy and the number of sample. Okay. So here, we use this ML flow model to track the model performance and as well as save and manage the actual model binary in the serialized format. For example, for a secondary model, it will save as a Pico format, and for a Spark ML model, it will save as a Parquet format. Right. So let me jump back to the Ignite IQ. Okay. So at this point, we already created a model using this Ignite IQ element tool. Let's move on to the next step, which is we want to start annotate, prepare our data set for the model training. So as mentioned earlier, the whole Ignite IQ tool is designed to manage the complete life cycle for machine learning, starting from the data preparation. So let's say if you have
maybe one comment here, Hanfei, is I think we see a lot of struggles around getting the training data and how do you get that training data, pass it back to your data scientist. And this tool allows you, sitting on top of OpenShift, allows you to get better training data, annotating that data, so then ultimately your data scientists and engineers can look at it. So go ahead, Hanfei.
Yep. Okay. As you can see, we have 3 Ignite models already loaded in this Ignite IQ. Again, its backend is read from MLflow, and the model I'm going to demo is a start date model. The first thing is we want to have a set of label data for our model training. As Kevin mentioned, this is often hard, right, for the data scientist to get the training data if this is a supervised learning model. And for our start date model, we need a bunch of contract data, the raw PDF, and for the SME from business side or data scientists, they can use this Ignite IQ tool to manually label our target result from each raw documents. As you can see here, we already have the label for the start date, and the extra text is shown here. The reason we can show the extra text is all the documents, raw scan PDF is already OCR. So we do have the OCR text result the backend. So let's say if I draw another bounding box in the different area, you will see like it will return like the actual text data from OCR. So in this way, the SME or data scientist can quickly label the documents, right? By just draw a bounding box around the information they need, and move on to the next document.
And maybe just to add a little business context here is what we traditionally see is business users might want to get certain information out of unstructured data sets. So for instance, if it's a contract, they might want to pull out the contracting terms, or they may want to pull out the effective date or the the completion date of the contract and be able to make business decisions on that. Are they getting the right services for their contract? Is it something that maybe is dealing with LIBOR where you have to figure out what the new rate is to be changed? So traditionally, business will ask a lot of questions to documents. Those questions have answers that are in the documents, and the annotation process allows us to annotate those answers, specify them where they are inside the particular the Loom or the output from the OCR process, and then allow the data scientist to figure out if they want to use some type of machine learning model to be able to extrapolate out the information or some other technique. to consistently find that right information, so decisions could be made, from the business side. So that's one of the areas of it. You can also do straight classifiers. If you have a bunch of documents, you want to classify them to different categories, you can label them that way as well, and then the data scientist can see the information to start building their models.
Yes, Kevin. Yep. Okay. Once you finish the manual label for the training data set, we can execute the model and generate the accuracy for the training data. Because normally the training, the data center may run like multiple experiments, multiple runs. You can also track the accuracy distribution and the accuracy trend, right, from this history chart. Again, all the metadata performance metric will be stored in the ML flow and the real-time track here. Moving on to the test, similar to the training data set, we also want to prepare the label data for the test set. Again, data scientist or SME can log into each documents and manually draw the bounding box for the actual label. And once it's complete, they can generate the test data set accuracy for the training model. Once the model fully tested, we can move on to the last step, which is hold out data set. So you can use this data set for validation your model. And each data set is the new documents and the model never seen before. So by create a new holdout set.
And this is where we envision having a business SME coming in to start doing the validation of your data sets, of your holdout. So how accurate was the actual model itself?
Yep. Once SME prepares a holdout data set, they can use the test per training model for processing each document. And the model will generate the default predicted result with the accuracy. And at this point, we do see some result output by the model looks correct to us, but some of the result is off. So we'll start the menu intervention step to go through each model result and either accept the result or correct it. For example, for this document, the result looks good to me, so I can accept the result. And this result is also looks good to me. Okay. And moving on to the next one, seems like this detection is off. We can reject it and manually correct the right start date. For example, let me pick up this one as our effective start date. Okay, and let's save this result here. So what happened is we just correct this document result generated by our pre-trained model to this correct information, and for the next training or next model updates, it will automatically use the correct information label to retrain our model, right, to correct the result.
And Hongfei, maybe something to mention there. When we initially talked through this, we said that all of our data is stored in a Loom, and this is the same concept for when you're using these inputs for the business, the annotation UI. So when the data scientist gets the output of the corrections that the business is making or the inaccuracies that they had in their prediction, they get to see that information into the Loom to then retrain their models or update their rules or whatever they're doing to try to extrapolate out that information. So again, one of the things we had data literacy is how do you kind of have the understanding of data through the life cycle of this process. And one of the concepts here, we have our core concept is our Loom, to store, track, manage, and kind of the data through the life cycle of the program, or the project, I should say.
Yep. Okay. At this stage, we are pretty much done for the whole machine learning life cycle. And we can go back to our Ignite admin tools to upgrade our model status to complete, or if the model still need more holdout testing, you can keep it as a validation step. Okay. And all the whole tools is deployed on top of an Ignite platform. And yeah.
Perfect. Can you bring up the PowerPoint one quick time before you go back into OpenShift? I just want to show where you were in that life cycle right there.
Yep. This
so
work.
if you think about what we were doing, there was the activity of the OCRing, which was done already. That OCRing then feeds into those business input functions. So where you can start doing the annotations and where you can start kind of marking up your documents. That then goes back into the data scientist. And then once they do and they build and they train the model, there might be a smart sectioning model. For instance, they might want to break the document down into sections so they can more granularly, make predictions on the data sets that are being highlighted. They could add some spacey there to enhance the data to better find the information. But these steps along the path of after you OCR it, after the business comes in and gets the annotations and the markups, the next part then is to start breaking that problem down to be able to get the information out that ultimately you want to use to make your business decision. So again, we've kind of run one part of Ignite here to OCR it, so you can see the document on the screen like you did. The business will do the annotation. You start creating different models, whether it's a model for smart sectioning or you want to reuse this. You enhance your intelligent domain name engine. You add spacey to get better enrichment across of it. And then finally, what Hongfei will now show is these components will execute in a workflow that can scale up or down. So if you have to OCR, we know OCR is a heavier process. Maybe you have to OCR 1,000 documents. You can have 1,000 components that are running. Each time that component's complete, it's going back into Kafka to let Kafka know, and then your next component in the workflow is picking this up. So we'll do a small demonstration of the annotation's been done, the models have been built, and now you sort of want to execute this pipeline through these different steps to produce an output. And that's what Hongfei is going to show you now.
Yep. Okay, let me jump back to where we are for the Ignite platform. Okay, so just quickly show you different components we deployed. We have stateful side deployed for most of our storage application, including the object storage meow in the distributed mode, Zookeeper HA, Kafka HA, Elasticsearch, Postgres, and JFrog Artifactory. We also have a bunch of deployment type components shown here. Including we have the Spark MLlib component and a load balancer, Nginx, HBase API for read-write from HBase, annotation tools, component builder, etc. So after using the CI/CD to deploy the complete Ignite platform on the OpenShift, we can let data scientist or data engineer to use this platform to launch or create an arbitrary Ignite workflow for their machine learning pipeline. So the first thing.
And I guess I'd say just one quick thing. You're going to be using a Jupyter Notebook to show the ability to create a workflow, which is each component that you want to execute and then executing it through. Or, as we've seen some other clients, and we do it internally, you can call a RESTful service that sends in your workflow that also executes this end-to-end pipeline.
Yes. Yeah. So this is a Python SDK we created. It's called Ignite Connect. But as Kevin mentioned, you can also directly submit your workflow in the JSON format to launch your machine learning pipeline directly through the Ignite API. Yeah. But the demo I'm going to show you is using the Ignite Python SDK to create workflow and execute it using Ignite platform. Right. The first thing is we need to import several libraries, Python libraries for Ignite, and then we will define our workflow. Here, the first thing is we will read some PDF, scan PDF image from the local disk, and then it will come to the the workflow definition. Here we will have several components we want to execute in this workflow. The first thing is because PDF is a scan PDF, we need to convert from the PDF to the image. We are using this PDF tool and we call it a page scanner components. You need to specify component name, package name, Docker image with the tag information here. Based on the number of documents you process, you can horizontal scale. You can set the number of pods you want to execute for this component in OpenShift, and also how many documents you want to run in one batch. As you can see, it's very flexible and highly customized for your own processing. Okay. The next component we're going to kick off is test-write OCR component. We also need to define some parameters that you want to pass through the test-write command. And similar to the first component, you need to define the package name, component name, image, Docker image with the tag information, instance, batch size, etc. We do have two more components, Spacey, which is running the NLP processing and intelligent domain engine to extract interest field right from the financial contract documents. Okay. So once you define each component using the Python SDK, the next step is you can create the workflow. So it's actually defines the workflow pipeline by defining data directed ACID graph DAG. Similar to Spark contests, at this point, it's still like a lazy evaluation. You just create the edge for the components, right? What components you want to execute in your pipeline, and with which order. And then it won't execute until you create the workflow and say kick off the workflow. So I'm going to run this. Since already
the infrastructure kind of foundational pieces of the platform exist, but none of these other containers are deployed onto the platform until the execution of the workflow. And then there's the determination of how many do I need? So how many OCR jobs do I need to run? How many containers do I run? And then we'll run in parallel, complete their job, and then they'll all shut down. So it's only using the capacity when it needs it, and then it shuts down and produces the output.
Yes, Kevin. And once we start the workflow, the job actually submit to the backend for the batch processing, so it's asynchronously. And to check the result, we can go back to our OpenShift and look at the pods here, and you will see. Okay, so you'll see we just finished the page scanner component, the first component. And it's complete, it's terminating right now, and move on to the next second component, which is test-write OCR, and it's launching the pod right now. Okay. Also, if you don't want to using the OpenShift portal to check the status, you can also using our SDK, which is the workflow.status. You can check the status from here. Okay, so basically it return all the component status in your workflow where they complete the page scanner, the first component, and now it's running the OCR. The rest of the component is in pending state. Let's see. Okay, so OCR is up and running. And go to the log and check the status of the OCR. So we have two PDF documents processing here. To here, let's refresh this to see when the OCR complete, and move on to the next component Spacey, so on and so forth. And once all the component, all the steps define your workflow complete, you will get a final result in the Loom format, and you can check what's the extracted field result looks like. Go back here and let's quickly see the OCR is still running. Right. Kevin, I think at this point that covered all my demo. We're just waiting for the workflow complete.
Great. So again, just to recap on what we saw, we went over a little bit on why we decided to invest in our overall Ignite platform. And apologies, I did get kicked off a little bit there. We had a storm that passed through, but we saw why we build Ignite, the kind of capabilities of Ignite. It's an open ecosystem built on containers, microservices that can plug into other offerings, so other cloud offerings, other data science offerings on-prem, and helps to manage the full end-to-end lifecycle deployment and productionalization, as well as model management of a model. Concepts built on top of a Loom, so Loom in, Loom out. It's easy for everything to communicate with that. And then at the end of it, it produces some type of output that's usually then fed to a downstream application. So there could be like an exception process where any of the predictions that need to go be reviewed go into an exception queue. One that could feed through in the business systems to help make those business decisions. But that was, I think, everything that we wanted to show. And again, apologies for a little off and on there with the connectivity. I know we only have about 5 minutes, so I don't know if there's any questions or any comments that anyone would like to hear. And I'd say maybe bring up that slide again with our names, because it does have our contact information in there.
Yeah. So actually, even with the storm outage there, I think you did a wonderful job here. And the comment that I wanted to make was I like the in the platform the recognition by KPMG of the data literacy component. And the user experience that you showed for tagging the data and identifying the data and training the data. I think that was pretty cool, and I haven't seen a lot of that done as well as you've illustrated it and demoed it here today. So thanks, Hong Fei and Kevin, for doing that. Because a lot of the projects that I see leave out. They talk about training the data, they talk about analyzing the data, but they don't really talk about who's scouting out the data. And one of the projects that I work doing a POC with has a role called data scout, who is they're the people who find the data sources, clean them up, and make them available for the data scientists and the analyst. And so what's really nice about this platform is it really recognizes and enables people who are doing that work to be part, have that platform available. And the tagging was quite nice. I mean,
yep.
I thought that was pretty cool bit, and a unique offering, I think, in some ways. And maybe I haven't seen every data science platform on the planet, but that was pretty cool. And I think that is one of the maybe a special sauce from KPMG, is you recognize the need for data cleanup and facilitating that role.
Yeah, absolutely.
Yeah, so that was really great. As well as I'll just jokingly say my handle on Twitter is Python DJ, and I'm a huge fan of Jupyter Notebooks. So I also think what you're recognizing here is that, like, the data scientists folks don't really want to know about the infrastructure. So
yep.
Creating an abstraction layer so that the data science and the people who are doing the analytics can build their pipelines or use their pipelines without having to go and understand what's under the hood, what a container is, install this whole thing. So the platform really does a very good job of doing the heavy lifting there. So I think that was well illustrated as well. Thank you for that.
Yeah, I think the other important part to that is, as you probably were aware, is a lot of our data scientists and engineers have a like for their own tooling and bring their own tool to the marketplace. And we knew we couldn't create something that was all encompassing of every tool that was out there. So there's a lot of opportunities to have those plugins as a new component to plug it in. So yep. You can call speech to text from Google or Azure or wherever that may be, and plug it into your platform. So you're still getting the full end-to-end, but using the best of breed for services.
Yeah, I think that's a very good point. So again, thank you very much, everybody who's bared with us through the thunderstorm. Kevin, where are you based out of? Are you in New England?
No, I'm right outside of Philadelphia.
Okay, well, close, yeah. So I grew up in Massachusetts, so I have a sense of rolling thunderstorms and power outages, and it was fun to see the lights go down. So
if anything, ironic, that hasn't happened in a long time, and it just so happened at the perfect hour that this demonstration was going on.
It's anything like that. With a live demo, there's always something, and interestingly enough, the technology didn't fail. It was the weather.
Yeah.
So Well done. And so thanks everybody for taking
Thank
the
you.
time to do this today. And if you have questions, please reach out to Kevin or Hong Fei. You've got their emails here, and we'll endeavor to put this maybe with some of the silent bits cut out up on our YouTube channel, which is YouTube RH OpenShift. And we'll see if we have any questions. I'm not seeing any here on any of the channels, but we'll definitely look forward to hearing more from you guys and perhaps diving a little bit deeper into what you're doing, going down the road with some of your clients or customers and internal folks that are using this platform, because it's really nice. So thanks for all the
Great.
hard work.
Thank you so much. Have a good day. Bye.
All right. Take care, guys.